For generations, modern physics has stood on a foundation of principles thought to be unshakable. We believed we had mapped the workings of the universe, from the birth of stars and galaxies to the very limits of space and time. These ideas shaped our textbooks, guided our missions into space, and informed our understanding of the cosmos. But when the James Webb Space Telescope opened its gold-plated eye and gazed deeper into the universe than ever before, it didn't find confirmation. It found contradiction. The images coming back weren't just fascinating, they were impossible. Webb captured entire galaxies, fully formed and glowing brightly, in a time when the universe was still in its infancy. One such galaxy, labeled CEERS 93316, existed just 230 million years after the Big Bang. By all known laws, that's far too soon for a galaxy to even begin taking shape. And yet, there it was, not a cloud of loose gas, but a structured giant with mature stars. More galaxies followed. Webb saw clusters of them, massive and complex, at distances that placed them far closer to the Big Bang than our models ever allowed. This isn't a simple anomaly. It's a cosmic rupture. Something is fundamentally wrong with how we think the universe grows. The physics we've trusted for over a century, the models of galaxy formation, the timeline of cosmic evolution, the very metrics of time and distance, may all need to be reconsidered. These galaxies weren't struggling to form in a hostile early universe. They were thriving, burning through their star-forming gas in short, furious bursts, forming structures we thought impossible at that epoch. To understand how dramatic this is, imagine discovering a skyscraper in a village where bricks haven't even been invented. That's the scale of the contradiction. For decades, we believed galaxies like the Milky Way took billions of years to evolve. Now, we see galaxies just as massive existing a few hundred million years after time itself began. The numbers don't add up. The theories begin to buckle. The deeper Webb peers, the worse the mystery becomes. Some of these galaxies appear to exist in clusters, implying that the process of formation didn't just happen quickly, it happened widely, with coordination we can't explain. Either our timeline is wrong, or there's a missing piece of physics on a scale we've never imagined. In both cases, the implications are severe. If the early universe could organize itself this rapidly, then our assumptions about gravity, matter, and time might be missing something critical. And there's more. Many of these galaxies seem to lie beyond the Hubble horizon, the theoretical edge of the visible universe. According to standard cosmology, light from anything beyond this limit shouldn't have had enough time to reach us. But Webb is detecting their signals anyway. That should be impossible. The light from these objects isn't just stretching across space. It's defying our understanding of the space it's traveling through. This forces a terrifying question. Do we actually understand how the universe expands? Because if these galaxies can be seen despite lying beyond the cosmic boundary, it suggests our grasp of spacetime is flawed. Either the universe is expanding differently than we thought, or the geometry of space itself is warped in ways we haven't accounted for. Perhaps even time behaves differently in the distant past than it does now. Webb's findings are forcing scientists to consider ideas once thought too radical to entertain. Some theorists suggest that time may not have begun at the Big Bang, but emerged later, like a property of entropy. Others propose that we might be seeing remnants from a previous universe, bleeding through into our own. A few are daring to question redshift itself, the very tool we use to measure distance and age. Could it be that redshift doesn't behave the same way in deep time? That the constants of physics may not be so constant after all? The implications are staggering. If these observations hold up, they could spell the end of the standard model of cosmology. The Big Bang, once our most sacred theory, may be just a rough sketch of a much stranger reality. The patchwork of dark matter, cosmic inflation, and early universe physics that we've trusted for decades is beginning to unravel. Dark matter, for instance, has long been the invisible skeleton of the cosmos. It was never seen, but its presence was inferred from the behavior of galaxies and clusters. Now, the way galaxies form so early and so fast might suggest we've misunderstood the role of dark matter, or worse, that it doesn't exist in the way we assumed. If gravity behaved differently in the early universe, or if matter interacted through unknown forces, then our entire framework needs to be rebuilt. What James Webb has revealed is more than deep space. It's a mirror held up to human understanding, showing us where the cracks have always been. Every image challenges what we thought was certain. Every redshift confirmed is another nail in the coffin of an old model. We built the Webb telescope to answer the biggest questions in the universe. Instead, it has asked new ones that may take generations to answer. But one truth is already clear. The universe is not what we thought it was. It's older, faster, stranger, and more dynamic than we ever imagined. And now, we're left staring into the cosmic abyss, realizing that our greatest discoveries may still be ahead, and they might rewrite reality itself. The galaxies James Webb is discovering, vast, ancient, and impossibly organized, are forcing cosmologists to question the very bedrock of physics. These structures shouldn't exist this early in the universe's timeline, not with the mass, maturity, and distribution they display. Our current models require dark matter to act as scaffolding for galaxy formation, but to explain what Webb is seeing, the amount of dark matter necessary would be so dense that it should collapse under its own gravity, forming black holes instead of galaxies. And in some regions, these formations appear where dark matter shouldn't have been dense enough in the first place. This isn't a calculation gone wrong, it's a fundamental inconsistency. If dark matter behaves differently in the early universe, or if its distribution radically contradicts our simulations, then we may not understand it at all. Worse yet, dark matter may not even exist. It could be a stand-in for something else entirely, a placeholder for a force or property we have yet to name. If that's the case, the structure of the cosmos might be governed by principles just as foreign to us now as quantum mechanics once was to classical physics. But the contradictions don't stop at structure. Time itself, the one dimension we all take for granted, may not be uniform. Some galaxies appear to have evolved faster than time should allow. Their stars are not only massive and bright, they seem older than the universe was when they formed. That's more than a red flag, it's a cosmic siren. It suggests that time might not flow the same way everywhere. Under extreme conditions, perhaps time stretches, contracts, or even unfolds in ways we don't yet understand. This opens the door to radical interpretations of reality. What if the speed of light has not always been constant? What if gravity worked differently when the universe was young? Some physicists are now entertaining the possibility that time is not a fundamental dimension at all, but something emergent, a statistical phenomenon that appears only when entropy reaches a certain threshold. In that view, time isn't a river. It's a fog, sometimes dense, sometimes thin, sometimes looping in on itself. The Webb images might not just be snapshots of distant galaxies. They could be glimpses into regions where causality is tangled, where the flow of time isn't linear, and where the rules we follow no longer apply. If this is true, then it's not just that our equations are outdated. They're written in the wrong language altogether. And then there are the stars. Among Webb's most startling discoveries are signs of what may be population 3 stars, the first stars ever to form. These metal-free giants, composed only of hydrogen and helium, were expected to be massive, hot, and short-lived. Until now, they existed only in theory. But what Webb appears to have detected are stars that don't match any known life cycle. They are too massive, too hot, and too chemically primitive to fit into any model of stellar evolution. Some astrophysicists are even suggesting they might not be stars at all, but pre-collapse events, structures on the verge of becoming black holes, yet somehow igniting in ways we've never imagined. If this is confirmed, the implications are enormous. These objects could challenge everything we know about nucleosynthesis, the process by which stars forge the elements. They could even suggest forms of matter and energy we don't yet have the vocabulary to describe. But the strangeness goes further still. In Webb's deep field images, scientists have started noticing patterns, subtle repetitions in structure, alignments in the spin of galaxies, and symmetries that stretch across billions of light years. These aren't just chance. The statistical significance of these patterns has become difficult to dismiss. And they suggest something deeply unsettling, that the large-scale structure of the universe may not be entirely random. Some theorists now entertain the possibility that the cosmos contains an intrinsic order not explained by inflation or gravity alone. A few have gone further, drawing on simulation theory to suggest that what we're seeing might be evidence of a programmed universe. Others reach back to ancient ideas of consciousness embedded in the fabric of reality, where information itself is the fundamental substrate of existence, an entity that not only remembers but possibly reacts. And the more Webb looks, the more it feels as if the universe isn't just revealing its secrets. It's responding to our presence. After decades of calculations, massive investments, and entire generations of theory, the James Webb Space Telescope hasn't just pointed us toward distant stars. It has torn open the sky and revealed a universe that contradicts nearly everything we thought we knew. Galaxies that defy gravity. Stars that shouldn't form. Distances that shouldn't be visible. A timeline that no longer aligns with our models. This isn't just an update to cosmology. It's a collapse and a rebirth. The scaffolding of our understanding is falling apart, and in the rubble, something new is emerging. Something raw, unfiltered, and deeply strange. The universe is not just bigger than we imagined. It's different in kind. And now, as we stare back at the cosmos, we are forced to ask not just what the universe is, but whether we've ever truly known how to ask the right questions at all. Because maybe the answers aren't waiting at the end of a formula. Maybe they live in the margins, in the paradoxes, in the mysteries we've ignored. Maybe the universe was never meant to be solved, only witnessed. And now, it's watching us watch it.